Hello friends, I welcome you to Letstute. This is Keshav in Tanika, and I would like to encourage you to subscribe our channel if you are not subscribed yet, and press on the bell icon so that you may not miss any notification from our behalf. And today we are going to talk about coordinate geometry. So there are different aspects which we are going to see through. So let's talk about what are coordinates. Okay, coordinate system first of all. Let's talk about coordinate system. So basically coordinate system is consisting of coordinate axis. Okay, so as we all know, there are two axes. This is horizontal one, x axis. This is vertical one, y axis. Fine. So they are called as coordinate axis, x axis and y axis. They are called as coordinate axis. Fine. Now whatever geometry is related to the points on this coordinate system, basically if you take any point, let us say this point, any point is positioned with respect to x and y, and therefore the address, we can say that location of that point is given with respect to x, I mean the x-axis, and y-axis. Therefore any point on the coordinate plane is taken as in 2D geometry, basically in two-dimensional geometry. It is given with respect to x axis and with respect to y axis. So therefore the point is represented by x comma y. So any point x comma y, in that the first one is always a point, location of a point with respect to x axis. Therefore that is called as x coordinate. This is called as x coordinate. And the second value represents the location of a point with respect to y-axis. So it is called as y coordinate. Okay. X coordinate is basically also known as abscissa, and y coordinate also known as ordinate. So this is the basic information about any point on the coordinate system. I repeat, the location of a point given with respect to x-axis and y-axis, and the location given with x-axis is called as x coordinate. Alternatively, it is also known as abscissa, and the location of a point with respect to y-axis is called as y coordinate, and alternatively it is called as ordinate. Okay, so now whatever geometry is related to these points given in the form of x and y is called as coordinate geometry. It's as simple as that. Okay, I repeat, there are so many points in this plane, and the geometry which we learn, or which we are going to learn with respect to these points which are in terms of x and y are called as coordinate geometry. Okay, fine then. So this was a short introduction for coordinate geometry. What all things we have seen, what is coordinate system, what are coordinate axes, how the points on the coordinate system is represented by x coordinate and y coordinate, and what they are called as alternatively. X coordinate is called as abscissa and y coordinate is called as ordinate. Hope I'm hope I'm making, hope you're understanding what I'm trying to say. Okay, if you're not, then please let me know with the comments so that we can understand what's going on exactly. Okay, fine. So this is the introduction for coordinate geometry. Now let's go to the one of the most important thing. Like before going into that, let's say let me give you some examples for this so that it will be much more helpful. Suppose there is a point here. Okay, and of course these are nothing but the number lines, right? X-axis and y-axis are basically number lines. X-axis is horizontal number line and y-axis is vertical number line. So definitely you're going to have numbers on this, right? The beginning point is origin, which is called as 0. Say there are different points 1, 2, 3, 4, 5, etc. Similarly, on the left hand side, we have negative numbers. I don't have to inform you all these things. You're already aware of these things. 1, 2, 3, dot, 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 and -1, -2, dot, dot. Okay. Suppose I want the location of this point. How do I go about it? I see that where it is matching the value on x-axis, I can see that it is 2. Similarly, I'll match with y-axis. It is again, I can see that it is 2. So this is how the point is located. Okay. So basically, they are also called as Cartesian coordinates. It's because French mathematician René Descartes have given this idea of locating points on the coordinate axis. Okay, so therefore they are also called as Cartesian coordinates. Fine. Okay, so let me write over here. They are also called as Cartesian coordinates. Okay, fine. So any point on the line on the coordinate system, you can write it with respect to x and y. Okay, and they are called as xy, x coordinate and y coordinate, and they're also called as Cartesian coordinates. Okay, fine then. So let's go to the first topic I wanted to discuss here is distance formula. Distance formula. Okay. So basically, when we have 2 points on coordinate system, let me draw this. Okay. So this is our x, this is y, and we have origin over here. We have 2 points. Let us say here is 1 point, and here is the second point. Okay. Let me say this is P1 and this is P2. So basically point 1 and point 2. Okay. And I want the distance between them. Sorry. Let's take from the line. Yeah. Okay. Let me draw only. Fine. Suppose I need this distance. Let us say it as d. Okay. I need value of d. So how to find? So let us say the coordinates of P1 is x1, y1, and coordinates for P2 is x2, y2. Fine. What do I mean by that? The coordinates of point P1 is x1, y1. So basically it is at x1 with respect to x, and it is at y1 with respect to y. That's the reason the coordinates of this point is x1 comma y1. Similarly, the coordinates for P2 is given as x2, y2. That means it is at x2 with respect to x-axis and y2 with respect to y-axis. Correct? And we need this distance. Okay. So what do you think? What is the distance from x1 to x2? It's very simple. You just have to subtract x1 from x2. You will get the distance between them. Correct? And what is the distance between them? y1 and y2. You just have to subtract y1 from y2. So the distance from here, this point to this point, is equals to this distance. Correct? So even this is called as x2 minus x1 because they both are same. Similarly, this distance, that is y2 minus y1, is equal to this. So this is called as y2 minus y1. So we have x2 minus x1 and y2 minus y1. And I want to talk about this angle. This angle is 90 degrees. Correct? So if I give names to this, I already have P1 and P2. Say this is P3. So P1, P3, P2 is a right angled triangle. Correct? So in triangle P1, P2 and P3, we need distance of P1, P2. correct? And it is right angled triangle, right triangle, correct? So P1, P2 is basically hypotenuse, correct? So according to Pythagorean theorem, what is Pythagorean theorem? Hypotenuse square equals to squares of the sum of the other two sides. So that would be P1 P3 squared plus P2 P3 squared, correct? Now, so this is P1 P2, let it be as it is. What is P1 P3? I mean, this distance is x2 minus x1, so we are going to substitute that. X2 minus x1, we have squared. What is P2 P3? That is, here it is already given here, y2 minus y1, the whole square. So therefore, when you want the value of P1 P2, I mean the distance which we are looking for would be square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Fine. So this is nothing but the distance formula which we are looking for. So this tells us that whenever we have 2 points x1 y1 and x2 y2 and we want distance between them, we can find it by the formula which we just now derived, that is x2 minus x1 the whole square plus y2 minus y1 the whole square. It's as simple as that. Okay, so let's solve some questions over here. Let me just make sure that uh, okay, any doubts here? Okay, nobody's online, I see. Okay, no problem. Fine then. Okay, so let's solve by some examples over here. Examples. Let us say there are 2 points 1 comma 2 and 3 comma 4. There are 2 points. So let us consider this point as x1 comma y1. Let us take this point as x2 comma y2, and we want the distance between these 2 points. Let us take it as a and this as b. So the distance of AB will be square root of, using the same formula, x2 minus x1, that is, this is the x2, correct? So 3 minus x1, x1 is here. So 3 minus 1 the whole square. Y2, that is 4, minus y1, that is 2 whole square, correct? So therefore that would be 3 minus 1 is 2 squared, 4 minus 2 it is 2 squared. So that would give us 2 squared plus 2 squared, that is 4 plus 4, and that gives us square root of 8. And we can also write it as 4 2s are 8. So since the 4 is perfect square, it will come out of the square root and it will be 2 root 2. So therefore the length of AB is 2 root 2 units. So this is how we can find the distance between 2 points with the help of the formula, correct? Okay, let's have some more questions. Fine, let us solve this one. Okay, we are given with a question. I mean, in that we are given with Kiran Kumari, no, section formula will be covered in the next lecture. Now we are going to cover only distance formula. Okay, fine then. So let us see what examples we are going to solve. Is we are given with 4 points. So say 1 7, B is 4 2, and -1 -1, and D is -4 4. So these are the 4 points given, and we are also asked us to show that it is a square. Okay, so A is 1 7, B is 4 2, C is -1 -1, D is -4 4. So we have to show that it is a square. So let me just draw a rough diagram over here. Okay, So let us say these are the vertices A, B, C, and D. So for square, what are the properties? Properties are that all the sides should be equal. So what we are going to do is, the plan is to find the length of AB, BC, and CD or DC, whatever, and AD. And we'll check all the lengths. If all the lengths are equal, then we can say that it is a squared. Okay, fine. Uh, so let us assign the values here. 1, 7, B is 4, 2, C is -1, -1, and D is -4, 4. So let us start with AB. So we are going to use these 2 points. So AB equals to square root of, hope you remember the distance formula. I'll write over here still, x2 minus x1 the whole square. So y2 minus y1 the whole square. So basically taking x terms, I mean taking the x coordinates together and y coordinates together, subtracting them and squaring, and then adding, and then taking square root. So in this case 1 and 4 will be subtracted. Suppose 4 minus 1 we are taking, so it will be 3 squared plus 2 minus 5 minus 7, it would be minus 5 squared. So we are going to get 9 plus -5 squared, it is 24, 25. So we are going to get square root of 34. Fine. So this is what we got from AB. Now let's go for BC. For BC, we are going to use these 2 points, correct? So square root of x2 minus x1. So 4 minus of -1 is +1. So we'll get 5 squared plus 2 minus of -1 is +1. So 2 plus 1, it is 3 squared. So we are getting 25 plus 9, which is square root of 34. Great. Length of AB and length of BC are matching. Let's move further. Let's find CD or DC. So for that, we need to consider these 2 points. So square root of -1 minus of -4, that is +4. 4 minus 1, it is 3. So it is 3 squared plus it is -1 minus 4, it is -5. So -5 squared. So we are getting square root of 9 plus 25. So we are getting square root of 34. Fine. So we can see that even CD is matching. Then if it is a quadrilateral, definitely AD is supposed to match. Otherwise it won't work. I'm just solving because it is not given. Basically it is a quadrilateral, I guess, but still I'm solving this. AD, because in a quadrilateral, if 3 sides are equal, definitely fourth one has to be equal, but still, okay. So I'm going to use 1 minus of -4, so it will be +4. So 1 plus 4, it is 5 squared, and 7 minus 4, it is 3 squared. So using this, we are getting 25 plus 9, and we are getting square root of 34. So we can check that all the 4 sides, lengths of all the 4 sides are equal. If we are taking 1, 2, 3, 4, so from 1, 2, 3, and 4, AB equals to BC equals to CD equals to AD. That means all the 4 sides of a quadrilateral are equal. So therefore, quadrilateral ABCD is a squared. Is a squared, correct? So that's it. That's an interesting question. It's right. We are given 4 vertices, and we are asked to find if it is a square. Good job. Okay. Let's move further. Okay. So there are different types of questions in this section basically. Here there is one more type of question. It says we are given 3 points. The example points are 1, 5, 2, 3, and -2, -1. Sorry, -11 are collinear. Oh, we have to check if they are collinear. 1, 5, 2, 3, and -2, -11. We have to check if they are collinear. Now, so first of all, let us give names to these points. Okay, let us say this is A, this is B, and this is C. So we have to show that A, B, C. I'll write here. Show A, B, and C are collinear. If we imagine via diagram, now if they are collinear, if they are on the same line, and we are supposed to find if they are collinear, I'm assuming that let us say they are collinear, then what will be the condition we'll be having? We can find AB, we can find BC, and when we add them, we should get equal to AC. Only in that case, we can say that they are collinear using distance formula. Correct? So once we have given the names to these points, let's find one by one. Let's find AB. Let us use this 2 minus 1 squared. So it is 1 squared plus 3 minus 5 squared, that is negative 2 squared. So what this will be? 1 plus negative 2 squared is 4, so it will be root of 5. Okay, fine then. So we are done with AB. Length of AB is root 5 units. Okay, now let us find the length of BC. For BC, we have to use these two, correct? So that would be negative 2, negative 2. So it will be negative 4, right? This minus this. So negative 2, negative 2. Negative 4 squared. It is 16, correct? 16. Negative 11, negative 3. It would be negative 14. If I'm not wrong, negative 11, negative 3, negative 14, and negative 14 squared would be 196. Okay, so let us see what we are getting here. So we will be getting 212. Okay, so this is what I'm going to get. I'm just checking. 202 plus, yes, 202 we are getting. Okay, now we are going to find the length of AC. So AC, we are going to use these 2 points, negative 2, negative 1. So that is negative 3 squared plus negative 11, negative 5. So it will be minus 16. Minus 16 squared. So we are going to get 3 negative 3 squared is it is 9, and minus 16 squared it would be 256. So this gives us what? This gives us 265. Hope I'm not wrong. Okay, 265. Now what can be done? We are going to check the biggest number if it is a sum of the two smaller numbers. Okay, so biggest number is this, but is it equal? We are not getting equal, I guess. Let us just check if we can simplify something. 4s are okay. 25s are no, it's not happening. So 4 6 are 24. No, it's not happening. Here 4 4s are 16. No, it's not happening. So basically they are not equal. Okay, so whatever the biggest number which we are getting out of 3 should be equal to sum of the two smaller numbers, correct? That's what this logic tells us, correct? This length is small, this length is small. On adding these two small lengths, we should get the bigger length, which is not happening here. So we can say that AC is not equals to AB plus BC. Okay, good evening, good evening. I'm not paying attention to the I'm just focusing on the solving part. So if you have, I'm in the middle, I'm just having a look at what people are going to write or you're writing. So if you have any comments, you can definitely write it down. If it is regarding any doubt in the question, I definitely clear it. Okay, so before moving any further, I just want to let you know, or I just want to request you, if you are not subscribed our channel, to please subscribe it. And if you are not, press the bell icon. Even if you're subscribed, press the bell icon so that you can never miss an update from us. And you can also visit our website www.letstute.com for a wide range of courses on maths and science. Okay, then let's continue. So from here we see that AC is not equals to AB plus BC. So basically AC is the biggest number, biggest length, and biggest length should be equals to the sum of the two smaller lengths if they are collinear. Since they are not equals, we can say that A, B and C are non-collinear. Okay, fine then, good. Let us take some more example. Okay, so there are different types of examples are available with me. I can use one by one. So there is a question which says that there are 2 points, 2 comma -5 and -2 comma 9, and there is, suppose here is the point and this is the point, and there is one more point which is unknown, we don't know. Okay, but we are informed that it is at the equidistant from both the points. Okay, so that's what they are trying to tell us. 2 comma -5 and -2 comma 9, and the question is to find the x coordinate of the unknown point. So this is the question. There is a point which is equidistant from these two given points, and we have to find the coordinates of this unknown point. So let us say this is A and this is B and this is C. So basically we are given that according to the scenario, AB, sorry, not AB, AC, AC equals to BC. That's what it is given. Let us apply the distance formula and equate them. What is AC we are getting? Okay, AC is x minus 2 the whole square plus y minus of -5, so that would be y plus 5 the whole square. So this is the length of AC. Okay, x minus 2 the whole square plus y minus of minus, that is plus 5 equal squared. And what about BC? Let's solve that. So BC is x minus of minus, that is plus 2 the whole square plus y minus 9 the whole square. So whatever conditions are given, I've just applied them. And okay, and there is one more condition which I missed. It is saying that this point is lying on x-axis. The point C is lying on x-axis. Okay, the unknown point is lying on x-axis. That's what they're saying. But is it useful? Of course it is useful, because any point on x-axis will always have the value of y as 0. Okay, so that means we can put 0 in place of y everywhere, because this point C is on the x-axis. Okay, so when we apply 0, now we can see what we are getting. Square root of x minus 2 the whole square plus this is 0. 0 plus 5 is 5. It's 5 squared. And on right hand side, x plus 2 the whole square plus y is 0. 0 minus 9, it's minus 9. Minus 10 squared, that would be 81. Fine. So this is what we have got till now. For getting rid of this square root, let us square on both sides. Squaring on both sides. So what that would be? When we square on both sides, square root will be disappeared. So we will get x minus 2 the whole square plus 81 equals to x plus 2 the whole square. Sorry, 81 is from here. I wrote here. I have to wipe this. It's not 81, it should be 25. Yes, because 5 squared is 25, correct? And x plus 2 squared plus 81. So this is what happening over here. Okay, so let's expand this using a minus b whole squared formula. That would be a squared, that I mean x squared, and 2 to 4x minus 2 squared is 4 plus 25. And in the right hand side we have a plus b whole squared formula, so x squared plus 4x plus 4 plus 81. Okay, so now what will happen is we'll take the like terms together. x square terms is anyway going to get cancelled because they both are same. So, and when we subtract it, it will be cancelled. And what we have now, minus 4x is, it is 4 plus 25, it is 29. And on right hand side we have 4x plus 85. Okay, now let us shift the values. Let's shift 85 to the left hand side, so it will be 29 minus 85. Let's shift negative 4x to the right hand side, so it should be 4x plus 4x, it should be 8x. Okay, and now 29 minus 85 is basically how much? So it is 6 and 7, it is 56. Okay, so negative 56 equals to 8x. So x equals to negative 56 divided by 8, and we are getting negative 7. So this is what they wanted. We wanted to find only x value. That's what that's why the condition is the point is lying on x-axis. So we have received over here. Okay, so this is the answer for our question. So hope you're understanding, and if you have any doubt, you can just let me know. Collinear, what is collinear? Okay, yeah, we have already answered you. Collinear is a set of points and property of they're lying on a single line. When the points more than 2 points, basically I'll explain you over here. For finding a line, for seeing the line, we always need 2 points, right? Like if you have any 2 points, so this here and here, you can definitely draw the line. Okay, you can definitely draw the line. So for 2 points, we will definitely have lines. But what about more than 2? We might have a line or we might not have a line. We might have a triangle, who knows? So whenever we have more than 2 points, we can definitely check if they are lying on the same line or not. When they are lying on the same line, we can say that they are collinear. When they are not lying on the same line, we say that they are non-collinear. That's it. That is the difference. Okay. Fine then. Okay. Let's find one more question. Let's solve one more question. Question says, find the relation between x and y, and that point x and y is equidistant from 2 more points, that is 3 6 and negative 3 4. So these are the 2 points, and we have unknown point xy, and we want the relation between x and y. That's what the question is. Okay, so how to find that? We are given with the condition that this distance, whatever this distance, is equals to this distance. That's what we are informed. Let us say this is a and this is b and this is c. We are asked to find the relation between x and y, and the condition is AC equals to BC. Both the distances, both the lengths are equal. Fine then, when we find the length of AC, we will use distance formula, square root of x minus 3 the whole square plus y minus 6 the whole square equals to, similarly, when you find the length of BC, so that would be x minus of minus, that is x plus 3 the whole square plus y minus 4 the whole square. Squaring on both sides will get rid of the square roots. So let us square on both sides. Squaring on both sides. So what we are going to get? We are going to get x minus 3 the whole square plus y minus 6 the whole square equals to x plus 3 the whole square plus y minus 4 the whole square. Now we are going to apply this a plus b squared and a minus b whole squared formula. So from here we are going to get x squared minus 2 3s are 6x plus 9, correct? And from here also a minus b whole squared, so we'll get y squared minus 2 6 are 12, so 12y plus 6 squared, it is 36. And in the right hand side again, here x squared plus 2 3s are 6x plus 3 squared is 9. And here y squared minus 2 4s are 8y plus 16. Fine. So these are the things we are getting. X squared is on both the sides, and with the same coefficient, we can definitely subtract it. Similarly, for y squared, we have both the sides with the same coefficient, so we can cancel them. Anything else we are going to cancel? Let us see. Negative 6x, negative 12y, 9 plus 36, it is 45. Similarly here, 6x minus 8y, 9 plus 16, it is 25. Okay, now let us shift this 25 to the left hand side. We get 45 minus 25, and let's shift these numbers to the right hand side. This is 12, by the way. So what we'll get, we have 6x already. When this term shifted to right hand side, we get plus 6x, and we already have 8y. When we shift this, we are going to get positive 12y. Okay, so what will be the answer finally? 45 minus 25 is 20, 6x plus 6x, it is 12x, and minus 8y plus 12y, it is 4y. Correct? 4y. What we can do is, we can see that the common factor is 4, so let us divide by 4. Divide by 4 on both sides. On both sides. So what we are going to get? 4 5s are 20, 4 3s are 12, 4 4s are sorry, we are dividing 4 5s are 20, 4 3s are 12, and it is 1. So we'll get only y. We are having x over here. Yes. So after dividing by 4 on both sides, what we got from here? We got 5. From here we got 3. From here we got only 1y. So basically we got 3x plus y equals to 5. Correct? What is the question? Question is to find the relation between x and y in the unknown point. So this is the required relation. Required relation between x and y. Understood? So this is what we wanted to find. So hope you understood. Let us just go through what all things we learned today. We have seen what are coordinate system. We've seen that a system is created by x-axis and y-axis because we are talking about two-dimensional geometry, and they are called as coordinate axis. And any point on the coordinate axis, we will take it as x and y, because we generally try to tell the location of the point with respect to x-axis and y-axis, and that is called as x coordinate and y coordinate. That's what we can see over here. X coordinate is abscissa, y coordinate is ordinate, and they both together are called as Cartesian coordinates. And then we came to distance formula, the first subtopic of the day. So distance formula is, first of all, we have derived that if we have 2 points, say x1 y1 and x2 y2, by using this formula we can find the distance between the 2 points. Correct? And we have seen some examples how to find the distance between them. And then we have done a question based on square. We wanted to check if it is a square. Then also we wanted to check if the 3 points are collinear. And now we also found the relation between x and y as per the question as it was asked. Fine. So before stopping, I want to request you again, if you have not subscribed, please subscribe. And if you have not pressed the bell icon, please press the bell icon to miss any updates from our side. Fine. Okay, then see you next time. And you can also visit our website www.letstute.com for a wide range of courses on maths and science. See you next time. Till then, take care.